Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is areas related to circles. This is the second video on this topic. In the first video, we introduced the area of a sector of a circle and the area of segment of a circle. If you have missed out that video, the link is given in the description box. You can go through that video. Now in this particular video, we are focusing on the extra punch problems or the hot questions. Pay attention here students and be ready with pen and paper. In the first problem, we are given an area of an equilateral triangle of 49√3 centimeters square. Taking each angular point as center, a circle is described with radius equal to half the length of the side of the triangle. Find the area of the triangle not included in the circle. So we are given a triangle ABC. Through the vertex we are drawing a circle, half the side of the radius being half the side of the equilateral triangle. So we can draw three circles here. We need to find the area of this blue colored shaded region. So how do we proceed, friends? If we look carefully, if we are knowing already that the area of triangle is 49√3 centimeters square. So the area of triangle is given. If we can find the vertex area of these three circles, 1, 2, and these three sectors of the sectors of this particular circles, we can find these red marked sector areas and subtract it from the area of the triangle. We can get the area of the shaded region. So for getting the area of the sector, we need two things. One is the angle, included angle. So what is the included angle here? Included angle in an equilateral triangle is 60 degrees. So we know it is 60 degree. Angle A equal to angle B equal to angle C equal to 60 degree. So included angle is known. Also we should know the radius of the circle. Then we can determine the area of the three sectors. But the radius of the circle is not given. However, area of triangle is given. So we know the area of equilateral triangle is √3/4 a square, where a is the side of the equilateral triangle. That is, small a is equal to AB equal to BC equal to AC. So √3/4 a square is equal to 49√3. That is given here. 49√3 is given as the area of the triangle. So √3 will get cancelled. A square will become 49 into 4. So A will be 7 into 2. A will be 14. So the side of the equilateral triangle will be 14 centimeter. So the radius of circle is half of that. So radius of circle is 7 centimeter. It is given here. Radius equal to half the length of the side of the triangle. Now we can easily determine the area of the shaded region. As told earlier, area of the equilateral triangle 49√3 minus 3 times the area of the sectors of 60 degree. So three sectors are there, each of 60 degree and of the same radius 7 centimeter. So what is the formula here? Theta by 360, theta is 60 here, 60 by 360 into pi r square. R is 7. If we solve this, we will get the area of shaded region as 7.9 centimeters square. This is the answer. Let us take another challenging problem. In this figure, find the area of the shaded region enclosed between two concentric circles of radius 7 and 14 centimeter, where angle AOC equal to 40 degree. This is given 40 degree angle AOC. We need to find the area of this shaded region. Let us assume that for a moment, if this shaded region was extending throughout, even this portion was shaded. This particular also was shaded. Let us assume for a moment. Although in the problem it is not shaded. If this was also shaded, then the area would be area of the outer circle minus area of the inner circle. So if we want to find the full area, this shaded area, then it is equal to area of outer circle minus area of inner circle minus area of small ABCD. This small ABCD also we need to subtract. The other one is easy. Area of the outer circle is known. If radius is known, we can compute that pi r square. Similarly, area of inner circle also known. So how do we compute area of this small ABCD? How do we compute that? We observe that if we take this sector OAC minus sector OBD, then we can get this small ABCD area which is highlighted by us. So we will compute that first, because the included angle in the sector is given 40 degree and the radius are also given 14 and 7. So we compute the area of this small ABCD as 40 by 360 theta by 360 into pi r square, pi 14 square minus 40 by 360 pi 7 square. We evaluate this, we get 51.33 centimeters square. So this is the area of this shaded small, which we have shaded here, ABCD. Now the area of this shaded region which we want to compute is given by complete area of the bigger circle minus area of small circle minus area of small ABCD, which we already computed. So pi r square minus pi 7 square minus 51.33, we will get the area of the shaded region as 410.6 centimeters square. This is the final answer. Let us take a much simpler problem here. Find the area of the shaded region in the figure. This is the figure and this is the shaded region which we want to compute. If RP equal to 24, RP is 24 and PQ is 10 centimeter, this is 90 degree and O is the center of the circle. So how do we find the shaded region? Area of the shaded region is area of the semicircle. This semicircle ORPQ, this semicircle minus the area of triangle PQR. So we will get then the area of the shaded region. So what is RQ now? RQ is the hypotenuse for this right angle triangle. This is 24, this is 10. So RQ will be square root 24 square plus 10 square. If we take the square root, we will get 26. This is the diameter of the circle. Now we divide it by 2 to get the radius of the circle as 13. Now the area of the shaded region is area of the semicircle. What is the area of semicircle? Pi by 2 r square. So we have written pi by 2 r square. R is 13. Minus area of triangle. What is triangle area? Half base into height. Minus half into base 10 into height, which is 24. We evaluate this, we will get it as 145.5 centimeters square, which is the area of the shaded region. In this particular problem, PQR is the diameter of a circle. PQR is the diameter of a circle of radius 6 centimeter. The length PQ, QR and RS are equal. PQ equal to QR equal to RS. Semicircles are drawn on PQ and QS as diameter. So we are drawing PQ diameter and we draw a semicircle here. Similarly, QS is the diameter, we draw a semicircle here. Find the area of the shaded region. So how do we compute this? We observe that the area of the shaded region is area of semicircle PQRS. PQRS, this complete area, minus area of semicircle QRS. QRS is this. So that will be the diameter and corresponding area will be this. So we are subtracting. So we will get this area. We will add this particular area PQ corresponding to this diameter PQ, we will get the shaded area. So this is the thing we want to find. Now PQRS is the diameter of this particular circle with radius 6 centimeters. So PS will be 12 centimeter. It is divided into three parts. PQ equal to QRS equal to RS equal to 12 by 3. So 4 centimeters. So PQ is 4 centimeter, QR is 4 centimeter, RS is also 4 centimeter. Now what is the area of the shaded region we described? What is the area of semicircle PQRS? It is pi by 2 r square. We know the semicircle area is pi by 2 r square. So pi by 2, this is 12. So 12 by 2 is 6, radius is 6, pi by 2 6 square. What is the area of semicircle QRS? This is 8 centimeter, this is 4, 8 centimeter, radius is 4 centimeter. It is a semicircle, so we divide by 2 minus pi by 2, 4 square. Plus the area of this small circle, which is pi by 2, 2 square. This is PQ is 4, so its radius is 2. So if we add all this, we will get the solution as 12 pi centimeter square. In this problem, OABC is a square with side 15 centimeter. OABC is a square with side 15 centimeter. We need to find the area of the shaded region. We observe that if we find this sector area and subtract the area of the square, we will get the area of the shaded region. For getting the sector area, we should know the included angle. Yes, it is given as 90 degree, and we should also know the radius of the sector. Radius of the sector is OB, but OB is not given here. We will find out OB first. So what is OB? OB is the diagonal of this square. So what is the length of the diagonal? Length of the diagonal is root 2 times the length of the side. So if the length of the square is 15 centimeter, the length of the diagonal OB will be 15 root 2. So now we got the radius and the included angle, we will get the area of the full sector. So 90 by 360, 90 is the included angle here. 90 by 360 into pi r square. R is 15 root 2. So pi 15 root 2 the whole square minus the area of the square. So we will get the shaded region. If we evaluate this, we will get the area of shaded region as 128.4 centimeter square. Let us move on to another interesting problem. Here a calf is tied with a rope of length 6 meter at the corner of a square grassy lawn of side 20 meter. If the length of the rope is increased by 5.5 meter, find the increase in the area of the grassy lawn in which the calf can graze. Let calf be tied at point D, and initially it is connected by a rope of 6 meter. So it can cover this light square, light shaded area. So it will cover D, P, Q for grazing, which is the area of a sector. Now we increase the length of rope by 5.5 meters. So length of the rope is increased. So then the new radius will be 11.5 meters. 6 plus 5.5. So we will add that. Now it will be able to graze DRS sector, DRS as the grazing area. Now what is the increase in area? Increase in area is given by the dark region here. So area of shaded region PQRS, which is the dark region here, is area of sector DRS, that is the complete here sector, minus area of the light shaded, we will get the dark shaded one. So we can easily deduce the included angle for the sector is 90 degree and the radius, two radius are 6 and 11.5. So we will compute the area of shaded region as 90 by 360 pi r square, this 11.5 the whole square, and next is 90 by 360 pi 6 square. So if we evaluate this, we will get the area of shaded region as 75.6 centimeters square. With this friends, we conclude this video and request you to please subscribe this channel and give a thumbs up to this particular video. This will motivate me to make more such good videos for you. Thank you very much.